Mr. Bowman here. In this video, we're looking at 2.7 calculus methods, and we're focusing on all the excellence questions from that 2017 exam. So let's get straight into it. We're going to get into question number 13. These are from the website. I've got the link in the description below that. But we've been told a tangent to the graph with this function has a gradient of 2, and it passes through the point 5a. Basically, we're trying to find out, well, what's the value of a? So the way I'll be starting this question, as always, I'm going to jot down the function I've been given. So fx is equal to 3x squared minus 4x. And I'm going to go ahead and differentiate that. And I'm differentiating that because I've got some information about the gradient. So it makes sense that I need a gradient function to continue. It's going to be 6x squared, or no, 6x minus 4. I've been told the gradient is equal to 2. So what that means is f dash x is equal to 2. So I'm going to equate these two here and solve for x. So 2 is going to be equal to 6x minus 4. I'm then going to go plus 4 plus 4. So that means 6 is equal to 6x, resulting in x being equal to 1. But what that tells us, if you think of your kind of axes, we've got a parabola and we've got a tangent at this particular point. We've been told, or this point, it would be 1 comma something. So we can find that something by putting it back into the original function. Don't put it back into the gradient function, but back into the original one. So f when x is equal to 1 is going to be equal to 3 times 1 squared minus 4 times 1. That there just becomes 3 minus 4, which is equal to negative 1. So that means the coordinate for when the tangent touches the parabola would be 1 comma negative 1. The issue with this question is we're looking at another point on that tangent, 5 comma a, and we're trying to find out what that a value is. So we need to figure out the equation of the tangent before we can do that. So the tangent general equation will be y equals mx plus c. We don't know the constant, so we don't really know that y-intercept, but we do know that x is equal to 1, which is from the point that we had above. That also means y is equal to negative 1, and also gradient equal to 2, and we had that earlier on in our working. We're going to substitute all three of these into our y equals mx plus c. That will leave c as the only letter left, so we can go ahead and solve for c. So we've got minus 1 is equal to 2 times 1 plus, oh gosh, I wrote 2 times 2, plus c. So we're then going to go minus 2, which means c is equal to negative 3. So that means our tangent formula is going to be y is equal to 2x minus 3. This is now how we can link it back to find a. We know that x is equal to 5. So if we plug that in, we'll be able to find y. So as I said, x is equal to 5. So we're going to get y is equal to 2 times 5 minus 3. That there is 10 minus 3, which is equal to 7. And that there is our a value. We have now moved on to question number 14. And just a bit of a disclaimer, this question was pretty hard when I first looked at it. And it involved some simultaneous skills that I haven't really seen in too many of the other excellence questions in calculus. So in the back of your head, when you're doing these exams, if you've got multiple variables, don't be afraid to think of simultaneous equations. So we've got the function, and notice it's got two other variables, a and b, and we've been told that the turning points are negative 1 and positive 3. We've been asked to find the values of a and b in the original function. So let's start off by jotting down, as always, the original function. Fx is equal to x cubed plus ax squared plus bx plus 2. We're dealing with turning points. So at those turning points, we know that the gradient, or f dash x, is equal to 0. And that meant x would be negative 1, or x would be equal to positive 3 at that particular point. So because we have information about the gradient function, f dash x equals 0, we need a gradient function to go ahead and substitute into. So let's differentiate. F dash x is going to be equal to 3x squared plus 2ax plus b. At this stage, this is kind of where the simultaneous equations come into. So I'm just going to split it up into two equations. For the first equation, we're going to substitute 0 and negative 1. And for the second equation, we're going to substitute 0 and positive 3. That'll leave us with two equations with two unknown variables. So 0 is equal to 3 times negative 1 squared plus 2a times negative 1 plus b. And the next equation, 0 is equal to 3 times 3 squared plus 2a times 3 plus b. Now that we've done that, we're just going to go ahead and simplify. So 1 squared is 1. So 0 is going to be equal to 3 minus 2a plus b. And on the other side, 0 is going to be equal to 3 squared is 9 times 3, 27, plus 6a plus b. So at this stage here, got a couple options. You can see the clear simultaneous equations now. You just got to think, what are you going to substitute into what? And I'm probably going to focus on the b's just because they seem easier to deal with. If I move this to the other side, that's going to become negative b. So negative b is equal to 3 minus 2a. And same on the other side, negative b is equal to 27 plus 6a. Just noting, it's a bit weird to deal it with a negative b. And the reason I've chosen to do that, because if you have a look, 4 out of 3 of those are positive. If I don't deal with negative b, I'll change all of the positives to negatives. And I feel like I'm just more likely to do a silly math error on the way if I do that. Okay, so we've now got our two equations. Let's substitute them together. So 3 minus 2a is going to be equal to 27 plus 6a. We're going to go plus 2a, and then minus 27 minus 27. So negative 24 is equal to 8a, and divide by 8, a is equal to negative 3. So that's the first part of the question. We found out a. We're now going to substitute a equals negative 3 into either of the equations that we have above, just to find out what b is going to be equal to. So let's deal with this one here, just because the numbers look smaller, probably easier to deal with. So negative b is equal to 3 minus 2 times negative 3. So negative b is going to be 3 plus 6. Negative b is equal to 9, which means positive b is equal to negative 9. And that's the second part of our equation. If you can get both a and b, that's how you're going to get your excellence part. So as I said at the beginning of this question, a weird question. Haven't really seen simultaneous equations come up too much before. But be aware, it could come up. We are now looking at question number 15. Use calculus, so they're pretty clear about it. Use calculus to find the value of k for the line, which is a tangent, that's y equals 6x plus k for that particular function. So as always, let's start off by jotting down the original function. That's x squared plus 2x minus 1. And what we've got from the tangent, so we know that y is equal to 6x plus k. What that tells us is that 6 part, that tells us we're dealing with a gradient, or that tells us that f dash x is equal to 6. So we've got some information about the gradient function, so we're going to need to differentiate to find that, which means f dash x is going to be equal to 2x plus 2. So because we know it's 6, we're going to substitute that in, and we're going to solve for x. So 6 is going to be equal to 2x plus 2. We now solve minus 2 minus 2. 4 is equal to 2x, which means x is equal to 2. So that means, because we're dealing with a parabola and a tangent, the x value for the point where they touch is 2. Okay, we now need to find out that y value, so we need a bit more information, and this information is an x and y value for the tangent. And what we'll then do is, once we know x and y, we're going to substitute that in to then solve for k. So let's find out what that y value is. So f when is equal to 2 is going to be 2 squared plus 2 times 2 minus 1. 2 squared plus 2 times 2 minus 1, so that's 4 plus 4 minus 1 is 7. So that gives us the other value for our coordinate, 7. So with respect to our our tangent, y is equal to 6x plus k. We now know that x is equal to 2 and y is equal to 7. We're going to substitute that in. So 7 is going to be equal to 6 times 2 plus k. 7 equals 12 plus k minus 12 minus 12. K is equal to minus 5. And that's all we've been asked to do is we've been asked to find the value of k. If you're asked to find or state the whole equation, make sure you do separately. But there you go, k equals minus 5. Okay, so we are now looking at question number 16. And we've been asked to use calculus to show that the function has a local maximum when x is 9 over 4. And we've been asked to justify that the turning point is a maximum. That probably means we need to look into the second derivative later on. And because it's a maximum, we know that f dash x will be equal to 0. So we've got our function. We're probably going to need to simplify, differentiate that, and then differentiate again to get the second derivative. So let's jump in. So we know y is going to be equal to x cubed 3 minus x. This is in the wrong form, so we're going to have to expand and simplify. That gets us to 3x cubed minus x to the power 4. Our gradient function y dash is going to be equal to 9x squared minus 4x cubed, and our second derivative is going to be equal to 18x minus 12x squared. We've done all our differentiating. Let's focus on f, or the first derivative, and we know about this maximum. We know it's a turning point, which means it's going to have a gradient of 0. So we know that y dash will be equal to 0 at that particular point. So we're going to substitute. So 0 is equal to 9x squared minus 4x cubed. We're going to go ahead and solve for this. So I know that there's an x squared in common, so I'm going to factorize that out, which makes 9 minus 4x. I'm now going to solve x. Well, the first value of x will be equal to 0, and then the next one will involve a bit of work. 9 minus 4x equals 0. We're going to go plus 4x plus 4x. So 9 is equal to 4x, divide by 4, divide by 4. X is equal to 9 over 4. And you might be like, oh, yeah, I've heard that number before. That was the number they've given to us. And in this type of question, often they'll give you the answer. It means it'll be your job to go ahead and solve it. So you'll be confirming the stuff in the question, basically. Okay, so that's the x values. So we've got one up here and one over here. And I should be specific that there is x2. And I now need to get into the second derivative test. So I've confirmed it is a turning point. I now need to confirm that it is a maximum. And what we know about maximum is, in a particular maximum, the second derivative is always going to be less than 0. In other words, the second derivative is always going to be negative. So we now need to start dealing with the second derivative. So we know y dash dash must be negative. So what we're going to do is we're going to substitute in the x value that we know, which is going to be annoying because it's fraction, 9 over 4. And we're going to check, well, is y dash dash negative? Is it 0? Is it positive? What does it tell us? So y dash dash is going to be equal to 18 times 9 over 4 minus 12 times 9 over 4. And all of that is squared. We're going to simplify that. So 18 times 9 is 162. So that's going to be 162 over 4. We're then going to simplify that into C, minus 12 times 81 over 16. We're then going to simplify this bit over here. In an exam, I'd probably encourage you just to bang that into the calculator to get the final answer. Yeah, if you do, that first bit there, that's 40.5. And this second bit here is minus 60.75. And when you find your final answer, that's going to be negative 20.25, or negative 20 and 1/4. So that's really good. That is a negative number, which matches our prediction that a maximum needed to have a negative second derivative. So what we need to do is, as f dash x is equal to 0 and f dash dash x is equal to negative 20.25 at x is equal to 9/4, we therefore have a maximum. We'll call it a local maximum just to be really good with our terminology. Okay, we are now up to question number 17. And we can see phrases are really like velocity, distance, I saw acceleration before. So straight away, I know it's a kinematics question. I'm going to need my little flowchart. I know the displacement differentiates to the velocity, which differentiates to the acceleration. And I also know if I'm going in the other direction, that means I'm integrating. So let's jump into the question. So an object can move either direction on a straight track at an acceleration of -4. So what that tells us is A in terms of t will be equal to -4. That's with reference to a fixed point. When a recording of the object's motion begins, the object is 12 centimeters from P. So what that tells us is when t is equal to 0, the displacement in terms of time will be equal to 12 because it's 12 centimeters or 12 centimeters away. It's moving away from the object. That really just explains, it doesn't really give us information about positive or negative. It just means we're 12 meters away, and that's represented there. And finally, it has a velocity of 6. So that also tells us when t is equal to 0, the velocity will be equal to 6. So that's a lot of information we can use to substitute. What is the maximum distance? So we're trying to find the distance that the object is away from point P. We've also been asked to justify that this is the maximum. The first step we need to know is our questions are in relation to distance, so we need to double integrate to find out what the displacement equation is going to be. So we know that the velocity v in terms of t is going to be equal to -4t plus c. This is when that velocity point comes into play. We're going to substitute that in to find out what c is. So we know that 6 is equal to -4 times 0 plus c, which means c is equal to 6. So the velocity in terms of time is equal to 6. Oh, God, not 6, that's what c is equal to, -4t plus 6. I now need to differentiate or integrate this again to find out the displacement. So s in terms of time is equal to -4 divided by the power plus 1, t power plus 1 plus 6t plus c. That becomes -2t squared plus 6t plus c. I'm now going to substitute in the displacement formula that I know. So I know that when time is 0, st is 12. So 12 is going to be equal to -2 times 0 squared plus 6 times 0 plus c. All the zeros become 0, so c is equal to 12, which means our final equation for displacement is going to be -2t squared plus 6t plus 12. We've now got our displacement equation, and we now need to link it to the idea of the maximum distance. And this is really annoying because we need to get back to our thing. So maximum distance, back up to the top, we know that s dash x will be equal to 0. And that means we have to differentiate this, which, as you remember, is just the velocity equation. So if s dash t is equal to -4t plus 6, 0 is equal to -4t plus 6, 4t equals 6, t equals 6/4, which is equal to 3 halves. Because we're dealing with time, I'm probably going to change it to 1.5 seconds. Now that I know that the maximum distance away from P happens after 1.5 seconds, I'm now going to substitute 1.5 into the original displacement equation to find out what the distance actually is. So the displacement after 1.5 seconds is -2 times 1.5 squared plus 6 times 1.5 plus 12. All of that I'd probably be tempted just to put that straight into the calculator. That gets us to 16.5 centimeters. And that there is our final answer. So our maximum distance, 16.5 centimeters away. And we have justified it's the maximum distance by getting into the S-T being equal to 0. For completeness, justifying, you're probably going to want to second differentiate just to be sure. And we know S-T is going to be equal to the derivative of velocity, which is equal to acceleration. So because S-T is equal to the acceleration in relation to time, which is equal to -4, that tells us S-T is negative, which supports the idea that it is a maximum. Now looking at question number 18, and this is definitely the funnest excellence question that I've looked at. We've been asked to find the maximum volume of an open box. That is a box with the bases but no lid. That can be made with a rectangular piece of cardboard. So we've been told that the cardboard is 20 centimeters by 30 centimeters. And it looks like the square corners have been cut out to allow for it to fold up into that box shape. We've also been asked to justify that it's the maximum volume. The first thing we need to think of is, well, what do we mean about volume? Volume is equal to base times height times length. And the other issue is we don't really know the base, because the base will be this dimension here, and the height, the length, would be that dimension there. So it's a bit of a weird question, but if you label these small sides here x, so let's say all of these here x, when you rotate those sides forward, that becomes the height of the shape. So that tells us that the height, or h, is equal to x. That then gives us information about the base of the shape. So the total length is 30. We're then chopping off 2 x's. That means the bottom of that, or the base of the rectangle, is going to be 30 minus 2x. And the same can be said about the length. We've got 20 minus 2x. So that tells us the base will be equal to 30 minus 2x, and the length will be equal to 20 minus 2x. We're going to pull all this together to come up with an equation in terms of x. And don't forget, x relates to the base and the width of the squares that we're cutting off from the corners. So v is going to be equal to x times 30 minus 2x times 20 minus 2x. We now need to just simplify this into a polynomial. So we're just going to need to expand. So I'm going to expand the double brackets first. So x was equal to 600 minus 40x minus 60x plus 4x squared. Probably pay to simplify the middle part, group those x's together. X will be 600 minus 100x plus 4x squared. And then finally, we can do the last expanding to get us to, I'm going to do 4x cubed. So I did this first just so the cubed is out front. Minus 100x squared plus 600x. So that's the equation for the volume. I've been asked about the maximum volume. So at that particular point, so at the maximum, we know two things. We know that v dash will be equal to 0, and we know v dash dash will be equal to negative, or something negative. So both of those parts are going to come into play for this question. So let's differentiate first. So v dash is going to be 12x squared minus 200x plus 600. As I said, we know that v dash is equal to 0, so we're going to go all the way over here and substitute that in. So 0 is going to be equal to 12x squared minus 200x plus 600. Straight away I know, well, this is a quadratic. There's lots of factors in common we can get rid of, but it's a quadratic. I know it's going to be messy, so I'm going to jump straight into the calculator. A is equal to 12. B is equal to negative 200, and C is equal to positive 600. I put that into my calculator. I'm going to get two answers. The first answer for X, or X1, is 12.74. The second answer is equal to positive 3.2. Both of those are in centimeters, and both of those had a 2dp rounding. So what we've got is we've got two X values, and what that represents is because we had a bit of like a quadratic, that means we've got, well, there's the maximum, there's the minimum. We now need just to figure out, well, which one's which? Which one will give us the maximum volume? Which one will give us the minimum volume? So that then links us to the second bit of information. We know the second derivative will be negative at the maximum. So we're going to find the second derivatives for both of these. That'll help us tell which one's the maximum. So we know f dash dash, going to differentiate this. That's going to be 24x minus 200. We're now going to substitute them both in. So v dash dash when x is equal to 12.75. That there is equal to 24 times 12.74 minus 20. That gets us to positive 104.76. Noting definitely positive. And then v dash dash when x is equal to 3.92. That there is equal to 24 times 3.92 minus 20. That there gets us to the negative answer. So same but negative 105.92. And what this here has done is confirmed it's a negative second derivative, which means x2 or 3.92 is going to be our maximum. So as v dash is equal to 0 and v dash dash is negative, the maximum volume will be when x is equal to 3.92 centimeters, and that had a 2dp rounding. Guys, that wraps up the 2017 Excellence questions. Some real tricky ones there. I thought it was probably one of the harder exams going around. Hopefully you found it useful. Now let's keep practicing.